Welcome to our overview of our new product, Eriksson Sync, the integration of design and BIM. Eriksson Sync provides two-way synchronization of concrete extents, reinforcement, and lifting hardware between the Eriksson Commercial Suite and your BIM model. This includes support for Eriksson Beam, Eriksson Wall, and Eriksson Column. To facilitate this, we provide 6 main tools. The first of these tools is Design Part. Design Part takes information from the BIM model and transfers it to our design software. It can pull the concrete extents and reinforcement from the BIM model and either create new design files, modify existing design files, or create temporary files containing this information. The next tool is Reinforce Part. Reinforce Part takes the reinforcement information from the design file and populates the BIM model with reinforcement. This reinforcement can either be placed alongside what is currently present in the model or replace the current reinforcement. A set of options exists to help when the design file's geometry does not match that of the BIM model's geometry. This way, a single design file can be used across multiple marks with ease. Like Reinforce Part, Add Lifters to Part takes information about the lifting hardware from the design file and populates the BIM model with lifting hardware. Similar options exist on handle cases where the geometry does not match exactly. The user just needs to select what hardware to be inserted, and from there the primary and secondary lifting hardware is automatically inserted. The Design Manager is the next of our tools. This provides a different interface to use Eriksson Sync within and provides some additional functionality. The Design Manager is a database of all the precast elements within the model that Eriksson Sync supports. From this, the user can quickly associate BIM elements to design files as well as check these associations. The Design Manager also provides a way to easily perform bulk operations on multiple BIM elements at the same time. The next two tools are modeling tools available exclusively in Eriksson Sync for Tekla structures. The first is Edit Cross-Section. The purpose of Edit Cross-Section is a way to quickly edit the typical section of a selected element. The editing can be done by either manually typing in new properties or by selecting a design file on disk and using its properties. This tool can be used to convert one section type into another, such as converting a solid wall panel into insulated wall panels. This also works with any profile currently in your profile library. The last modeling tool is Add Solid Zone. This tool works similar to the way a polygonal cut works. That is, you simply select the object you want to add a solid zone to, draw the shape of the solid zone, and extrude it into the base part. This allows simple addition of solid zones to both hollow core slabs and insulated wall panels. To access Eriksson Sync, go to Applications and Components, then search for Sync. From here, simply click the icon and Eriksson Sync will launch. Here you'll find the icons for Design Part, Reinforce Part, Add Lifters to Part, the Design Manager, Edit Cross-Section, Add Solid Zone, Settings, and Help. The purpose of Design Part is to take information from the BIM model and transfer it to our design software. To access Design Part, use the leftmost icon on the Eriksson Sync launcher. From here, the tool can be run multiple times on the selected elements within the model. You can see that currently the path states no design selected. It says this when either no element in the BIM model is selected or when the selected item is not yet associated to a design file. In the top right corner, you can view the current settings being used. Here you dictate what information you want to pull from the model to the design file. Any information you include will replace that in the design file. For example, if you pull over any rebar, Eriksson Sync will remove all existing rebar from the design file and replace it with the rebar from the BIM model. In the bottom left corner, the Save Preferences checkbox tells the program to use these settings as the default settings from here on out. The ellipse button allows the user to select a design file on disk to use for the selected elements. The user can either select a pre-existing design file, which tells Eriksson Sync to replace the existing data in the file with the selected data, or create a new file containing only the selected data. If the checkbox Modify Associated Design File is unchecked, it tells Eriksson Sync to create a temporary file containing the same information as if using the selected design file. In this case, the original design file will not be modified, and trying to save the temporary file will prompt the user to enter a file name. The Run button will fire off the command. In this case, it will open Eriksson Beam using the selected design file as our base. The bottom left corner of the window gives the user the current status. For longer operations, this would also give the current progress of the operation. If any errors are encountered, clicking the expand button will display all of the errors and warnings encountered. After running the command, the selected elements will become associated to the design file. You can see that when the design software opens, the concrete extents looks a little different than what is typically expected. You gain a section in the middle that states concrete extents are being set externally from BIM and cannot be edited. Click here to manually define the concrete extents. This message appears because the design software has limitations on what kind of geometry it supports that the BIM model does not have. Although the inputs within our design software has these limitations, the analysis engine on the back end does not. Because of this, we pull over the true concrete extents to use for the analysis, unless the user bypasses that by clicking the link in the message. If that button is pressed, the design software makes an attempt to interpret the information into data the interface supports. The Design Part tool also supports multiple elements at the same time. Let's say we want to open multiple of our wall designs. Here, we can simply click on the two different walls. In this case, both of the walls are already associated to two different design files, which is made clear by the path switching to say multiple design files selected. For this case, when we press Run, Eriksson will open the two design files in two different tabs. At this point, synchronizing more information between these files is easily done by using the new Sync Data tool within our design software. Simply pick what data you want to be synced and press OK. If you selected a new design file before pressing Run, Design Part would have associated all selected elements to the new design file. The purpose of Reinforced Part is to take the reinforcement information from the design file and populate the BIM model with reinforcement elements. To access Reinforced Part, use the second from the left icon on the Eriksson Sync launcher. For Reinforced Part to work, the BIM element needs to be associated with the design file containing reinforcement. Once a design file has been associated, simply press the Run button and Eriksson Sync will populate the selected element with reinforcement. For longer operations, the bottom left corner of the window will give the user a status of the operation's progress. Eriksson Sync will also automatically cut mod reinforcement at all openings and remove all reinforcement that does not fall within the member. When running Reinforced Part on a member whose geometry does not match that of the design files exactly, it may be worth running Design Part one additional time. Doing this allows the engineer to quickly spot check using temporary files. Reinforced Part can also be run in bulk. For example, if we wanted to repeat the previous operation on all of the walls, simply select them all and press Run. Since one of these walls was already associated to a design file, we will use this design file for all of the other walls. Similarly, you can also run Reinforced Part on multiple element types at the same time. For example, we can pick a wall and a beam and update both of them simultaneously. This makes bulk refreshes of the model very easy. When performing bulk operations, having the right settings can make all of the difference. The settings dictate what type of reinforcement to populate the model with, and also controls where the reinforcement is placed within the element when the geometry is not an exact match. These settings include options for placement datums, grounding options, and mirroring for the placement position. Placement datums is one of the more powerful of these tools. It allows the user to dictate using the near side, far side, center, or nearest end as the placement datum. The datums work as follows. When determining where to position a piece of reinforcement in the BIM model, first we determine how far the item is from the selected datum in the design software. We then locate the same datum in the BIM model and position the reinforcement relative to it. This allows members to vary greatly in geometry, but still get the correct reinforcement. Mirroring can be used when a design is the same, but mirrored about an axis. For example, this option could be used for walls with an asymmetric man door, or for two walls that are mitered at a corner of a structure. You can set up your design file with the correct reinforcement once, and when running it on a mirrored panel, simply use the settings to mirror the reinforcement about its width axis. The grounding options are mainly used for mild reinforcement. By setting up grounding, you can guarantee that after running a reinforced part, the resulting reinforcement contains bar lengths that one would expect. The purpose of add lifters to part is to take the stripping and erection information from the design file and populate the BIM model with lifting hardware. To access add lifters to part, use the second from the right icon in the Tools section of the Eriksson Sync launcher. Add lifters to part will populate the model with both primary and secondary lifting hardware. The inserted hardware for these types is specified under the settings. For walls, you can specify the hardware used for face lifters and for edge lifters. For beams, you can specify the top face lifters and side edge lifters, which would mainly be used for spandrels which are cast on their side. And for columns, you can specify the face lifters and the end lifters. To select which hardware to use, simply click the ellipse button and select the component from the component catalog. If you want to not add a certain type of lifter, simply do not specify lifting hardware to be inserted. Also, in the settings is an option to pick the placement position. The first placement option is relative location, which will use the percent down the member, such as 0.2L or 0.8L for a too high lifting case. The remaining datums are the same ones used for the reinforcement locations, which will use the true location measured from the selected datum. When you are finished selecting the hardware and setting your options, simply press Run. You can see that lifting hardware is now placed on the wall panel. This tool also works for multiple items at the same time. For this case, simply select all the elements you want to add lifters to before pressing Run. When performing bulk operations, you cannot differentiate hardware between different elements of the same type. For example, running this tool on double T's and hollow core slabs, which are both beams, would put the same lifting hardware in both, just at different locations. If a lifter were to follow the location where it does not touch the member, such as in a blockout, Eriksson Sync will still leave the lifter at that location, just floating in space. This is done so the engineer can then move the lifter to a valid location on the member. The Design Manager contains a grid that lists all parts in the model with their associated design files and other important information for organization and sorting to easily perform all of Eriksson Sync's functions on any number of selected components. To access the Design Manager, use the rightmost icon in the Tools section of the Eriksson Sync launcher. The grid can be used to organize parts by a chosen column. A column header is dragged to the top of the grid to group rows according to that column. For example, dragging the type column header to the top of the grid will group the rows by type so that all beams, columns, and walls will be grouped together respectively. A second column header can be dragged to the top of the grid to group even farther within the original grouping, and so on. This allows parts to be sorted to easily perform bulk operations like setting design files or reinforcing parts. In addition to grouping, you can also do traditional filtering of the columns. The column header can then be dragged from the top of the grid back down to the grid to remove the grouping. The column headers can also be dragged left and right to rearrange the grid. Selecting elements in the model will highlight those in the Design Manager grid. Also, selecting items in the grid will highlight the corresponding elements in the model. This makes it easy to relate parts within the model to the information within Eriksson Sync. The Design Manager grid shows the design files associated with every element in the model. The design files can be set or changed by using the toolbar. The grid's context menu or drop-down menu in the design column can be used as well. Once the parts are selected, the designs can be set to a new design file a design file on disk, or cleared to remove the design association. To be able to set a design file, all selected parts must be of the same type. For example, walls can only be set to Eriksson wall files. If multiple types of parts are selected, then a design file will not be able to be set. The new and open buttons in the toolbar will be disabled, and the new, open, and existing menu items will be disabled in the grid's context menu. The strength of the Design Manager is in the ability to easily perform bulk operations. The difficulty of selecting multiple parts in the model is alleviated by grouping them in the grid. Once the parts are selected, a design file can be set, the parts can be reinforced, lifters can be added, or cross-sections can be edited. Bulk running operations here is also easy. Simply select all the elements within the grid and run the command you want to run. You can see here, we very easily ran reinforced part on 24 different walls. The parts type can be changed to allow it to be opened in different Eriksson design softwares. For example, a wall can be changed to a column, then it can have an Eriksson column file associated with it and open in Eriksson column. The default member type is based on how the part was created within the model. The purpose of Edit Cross-Section is to give the user a way to quickly edit the selected element's geometry. This editing can be done by either manually typing in new values or by selecting a design file on disk and using its values. Edit Cross-Section supports solid walls, insulated walls, columns, double T's, inverted T's, spandrels, L-beams, and rectangular sections. To use Edit Cross-Section, first select the elements in the model you wish to edit, then press Run. The editing is done by modifying the selected element's profile. Because of this, the method supports all native Tekla profiles, but also user-created profiles, as long as the profile is parametric. When editing a section, only change the values you want changed. Any field left blank will remain its current value. When bulk editing, this means you can change the thickness of multiple elements at once while leaving its widths alone. This way, panel layouts and flooring systems will not be disturbed by the operation. Edit cross-section can also easily create insulated wall panels. In addition to your concrete geometry, just enter in your installation geometry and you instantly have an insulated section that is created using a native Tekla panel object, not a custom component. This results in an object that is easier to work with. Add solid zone works similar to the way a polygonal cut works. That is, you simply select the object you want to add a solid zone to, draw the shape of the solid zone, and extrude it into the base part. The additional solid zone can only be added to a single part at a time and uses the base part's material as its own. Thank you for watching. Please visit us at ericssonsoftware.com, and if you have any questions, email us at support@ericssonsoftware.com.